Hi everyone. So now we are going to talk about laws of heat transfer. So actually three laws we have to study, and all the laws are like in our syllabus. It's not deleted. Okay. So first one, Prevost theory. Prevost theory is a basic theory. It's a very quite old theory. And after that, then Stefan-Boltzmann's theory is there, and Bain's displacement law is also there. So first Prevost theory, it says that it states that all the bodies emit thermal radiation. All the bodies emit thermal radiation at all the temperatures. At all the temperatures and above the absolute zero. Except absolute zero, all the bodies emit thermal radiation. What is the meaning of absolute zero? Absolute zero means 0 Kelvin. Absolute zero means 0 Kelvin. Except it's not we can't attain that temperature. It's very low temperature. It's minus 273.16 degrees Celsius. So it is absolutely impossible to have that temperature. But except that temperature, in all the temperatures, the body emits radiation. So irrespective of the nature of the surroundings. So wherever we place, that doesn't matter. It always emits. So you will have a doubt. How? Because in previous cases we discussed when one temperature is high, temperature of surrounding is high, temperature of the body is low, then only there will be a heat transfer. Now you are saying like all the temperatures, all the conditions, the temperature, thermal radiations will emit. So actually both are same. Both are correct. What the idea is very simple. You just imagine. So you just take your one hand and keep on your other hand. So you either feel very cold or very hot, little bit warm or hot. So it's because of thermal radiation. Every body is emitting thermal radiation. That is the idea. You touch anywhere. So I'm touching this. Okay, I feel a little bit cold. So if I touch someone, then they'll feel a little bit hot. So that process is a very fine example of what thermal radiation is, the emission of thermal radiation. And if there is absolutely no thermal radiations are going from one body to another body, suppose I place a body here, there is no thermal radiation is passing or exchanging between them, then we can call it as thermal equilibrium, absolute thermal equilibrium. That is actually very rarely, like it's almost impossible to have such kind of situation, because every time there will be a temperature difference between them. And at least thermal radiation, the rate of thermal radiation will be very less. For example, a hot body is there. A hot body will always emit more thermal radiation. It will not accept more thermal radiation from the surroundings. Suppose there is a very cold body. So cold body will accept more thermal radiations than it emission of thermal radiation. So this is what is all about Prevost theory of heat exchange. Next one is a little bit important, and one equation also we have to study. That is Stefan-Boltzmann law. Actually, Stefan-Boltzmann law says that the total amount of heat radiation, the heat radiated, the total amount of heat radiated per second per unit area of a black body is directly proportional to fourth power of temperature. It's absolute temperature. So what is this E? E is nothing but it is the heat energy. The amount of heat radiated, the heat, let me call it as Q, per unit time, T per unit area. Okay, so is it proportional to T raised to 4, or E is equal to sigma T raised to 4, where sigma is, what is this? Stefan's constant. This is known as Stefan's constant. Okay, what is the value of Stefan's constant? 5.67 into 10 to the power minus 8. Watt meter raised to minus 2, Kelvin raised to minus 4. Unit is important. Unit, you just check the unit. Watt, why watt? Energy by time, that is heat energy by time, that is power. Watt meter raised to minus 2, Kelvin raised to minus 4. Okay, and another thing, look at this. E is also, that is the amount of heat radiated per second per area, that is also equal to E is equal to E into sigma T raised to 4. This one is okay, that is Stefan's law, Stefan-Boltzmann law. But what is this E? E is known as emissivity. This equation, this is the original equation for all the non-black bodies. Like if it is an absolute black body, absolute or perfect black body, then you can use this equation. Which one? This one. Okay. So otherwise, if it is not a perfect black body, then emissivity E also you have to consider. Emissivity is nothing but it is the ratio of heat energy radiated divided by the ratio of heat energy radiated by a perfect black body. Okay, so that is E. So for in the case of black body, perfect black body, what is the value of E? E is equal to 1. E is equal to 1. So in the case of perfect black body, E is equal to 1. In all other cases, all other cases are given. Alright, so all other cases you have to use this formula. If E is equal to 1, then that is what is this. Okay, so emissivity also you remember, but the Stefan-Boltzmann law and Prevost's theory, that is very important. And now we have to discuss in thermal properties only one more law we have to discuss, that is Wein's displacement law, and it's very important. And I need you to take the textbook also, because in textbook beautiful diagram is given. So we will use that diagram and then we will learn about Wein's displacement law. Alright, thank you.